Let's go. Let's.
Welcome to our second video. The course is 437, and then that is digital signal processing, which you can summarize as DSP. So this will be our video 2. I will go to signals. Well, a signal, I've said in the beginning, carries information. We have two broad types of signals. We have continuous time signal. That one is always available, always having value. This is the time axis. This is either the voltage or the current, whatever it may be voltage versus time or current versus time. At every point in time, there is a value for the signal. But when we go to discrete time signals, that one will be like this. It will have values only at certain time interval. Maybe this is at 0, this is at t, 2t, 3t, 4t, minus t, minus 2t. T is the regular time interval. So, if between 0 and t, no value for the signal. At 0 we have value, at t we have value, at 2t, 3t, 4t, 5t, and so on and so forth. And this side too. Now, this is discrete time signal. This axis is also time. The y-axis can be voltage, can be current, depending on what type of signal we are talking about. Can be voltage, can be current. So this axis, the independent variable is time, t. And we write it like that. As time goes on, we stop writing it as 0. We prefer to just, forget the t, but we know that t is there. So I can write it as 3, 4, I can write it as -1, -2. Then in that case, the axis becomes L. So in this case, we can be talking of x of t. In this case, we'll be talking of x of n. So that's the first thing you distinguish between continuous time signal and discrete time signal. We're talking of t here, we're talking of n here. Know that there should be capital T there, but we say that let's forget the t, but we know in the mind of our minds that we are not talking of 0, 1, 2, 3, 4. We are talking of 0, talking of t, 2t, 3t, where t is the regular time interval. What is this t? T can be any value. It can be daily. That means t is everyday affair, isn't it? It can be every 3 days. It can be every year. For example, your birthday is every year, isn't it? For those guys born on February 29, their own T is 4 years. They only get to celebrate their birthday every 4 years. That's their own regular. The thing is that it must be regular. Exactly. It must be regular. So you have some type of watch at home, wall clock, that at the end of the hour it will do bang, the next hour bang. That sound is what? Is discrete time. It's not coming every time. It's coming occasionally. It's coming hourly. And the T in that case is 1 hour. The T can be century. T can be century, can be like that. So we have continuous time signal, we have discrete time signal. There's what we call waveform. What do you mean by waveform? Waveform is a plot of magnitude versus time. Is a what? A plot of magnitude against time. This diagram I'm drawing here are called waveform. Now, furthermore, when we are talking of signals, we should be able to have their mathematical representation as well as diagrams like this to describe them. In some of the materials I've sent to you earlier, I've introduced some type of signals. Let's deal with continuous time signal first, then we'll go to discrete time signal. When we talk of unit step signal, we represent it with u of t. And mathematically we say u of t equals 1 when t is greater or equal to 0. It is 0 when t is less than 0. That means in terms of waveform, it will look like this. The height will be 1. This is the time axis. This is 0. The signal will be 0 from 0 to minus infinity. It will be plus 1 from 0 to plus infinity. Now, there can be reversal, and there can be shifting. Reversal, and there can be shifting. There can also be scaling. Hello, I'm talking of 3 things: scaling, reversal, shifting. For scaling, if I give you 3u of t, that simply means what? The height is no more going to be 1 but 3. If I ask you to write mathematical expression for it, it will have been u of t equals 3 when it is greater than or equal to 0, 0 when it is less than 0. So this is like scaling. If I give you minus 7u of t, in this case, it will go down, isn't it? The height is going to be minus 7. This is 0, that is t. But when it is u of t, it is up, isn't it? When you put minus in front, so whatever you put in front can scale it. Now, I can also talk of shifting. I can talk of shifting. Will I give you? If I give you u of t minus 2, what does this imply? Whatever is in this bracket, please set it equal to 0. T minus 2 equals 0. Therefore, t equals 2. You know the shifting that normally take place at 0 will now take place at t. So if I'm drawing that, it will now be like this. The something that normally shifts at 0 will no more be at 0. It will now be where? At 2. So the height is still going to be 1 in this case. So let me remove this 0 and write 2 here. So that is shifting. The switching that normally takes place at 0 has shifted to 2. If I give you u of t plus 4, that means t plus 4 equals 0, t equals minus 4. So what will happen? It is at minus 4 that switching will take place. This is still the what? Time axis. If I give you 9u of t minus 9, this will be what? T minus 9 equals 0, t equals 9. So it is at 9 that switching will take place, and the height is going to be 9. The height is going to be 9. That is shifting. Let me introduce reversal. Reversal. If I give you u of minus t, whenever there is minus in front of t, the thing will switch at 0, but it will go to the left instead of the right. So I can say u of minus t is 1 when t is less or equal to 0. It is 0 when t is greater than 0. So the height is still going to be 1. Whenever there is minus in front of t, that will be reversed. You remember your ut. Your u of t is like this. That's your u of t. So your u of t used to be like this. There will not be a reversal about that. Isn't it? About 0. So instead of it being like this, going that way, that is to your left, right? That is to my left. It will now be what? To my right, when it becomes u of minus t. If I give you u of 2 minus t, what will this mean? 2 minus t equals 0, t equals 2. Then the switching will take place at where? At 2, and it will still go to my left like this. It will go to my left. So the height, if I put 8 here, the height here will simply be 8. This is about unit step. This is about unit step. That is unit step. Now, unit steps can be combined for more complex signal. Suppose I give you that a signal f of t equals 4u of t plus 5 minus u of t minus 1 plus 2u of t minus 4, then minus 7u of t minus 9. Now, we are adding 4-step functions together. How do we do it? Take it one by one and combine them. Let's take 4u of t plus 5. That one, switching will take place. So the first one, switching will take place at where? Switching will take place, t plus 5 equals 0, t equals minus 5. It is at minus 5, switching will take place. That will be 4. And the next one, switching will take place at where? T equals 1. 1 will be to this side. If I write 1 here, I don't know what I'm doing. Because when you can't incrementally to that direction. So 1 will be somewhere here. And then the height is going to be minus 1. The height is going to be minus 1 because of this minus. Then the next one is like this. This axis is time. The next one, switching is going to take place at t minus 4 equals 0, t equals 4. 4 should be somewhere here. You don't need to draw to scale, but at least if you put 4 here now, you don't know what you are doing, isn't it? So 4 should be to this side. If that is 4, the height is going to be 2, it's going to go like that. Then the last one is such that if this is time, then switching is taking place at 9. 9 should be somewhere here. 9 should be somewhere here. 9 will not be between 1 and 4. If you put 9 here, you don't know what you are doing. So 9 should be somewhere there. Switching will take place there. And then it will be minus 5. It is now time to combine. It is time to combine them together. When we are combining, you have to start asking questions. This is FT I want to draw now. This is the combined signal I want to draw now. Now, let me start from somewhere like minus 8. For example, minus 8. At minus 8, nothing is here. 0 is here. 0 is here. 0 is here. 0. Oh, this is an error. This is an error. This should not come to this side. It should go to that side. This is minus 5. Because it is u of t, not u of minus t. If it had been u of minus t, what I drew before would be correct. Now, if I start combining them at minus 8, I'm adding 0, 0, 0. No contribution from anybody. It's going to be 0. Up to where? Up to minus 5. At minus 5, this guy is contributing 4. So this will write here to 4. Then up to where? Up to 1. That will continue up to 1. When we get to 1, this guy is bringing 4, this guy is bringing minus 1. That will give us what? 3. So this will drop to 3 here, and you go like that until you get to 4. By the time we get to 4, this guy is bringing 4, this guy is bringing minus 1, making it plus 3. This guy is bringing 2, making it plus 5. Making it plus 5. So by the time we get to 4, it will rise to 5. And then that will continue up to where? Up to 9. By the time we get to 9, when you add, this guy is bringing plus 4, minus 1, making it 3, plus 2, making it 5. This guy is bringing minus 5, making it 0. So at 9, it will come down to 0, and that 0 will continue this way. 0 will also be here. This is our f of t. This is our f of t. Because of the size of our video, let us stop here. We'll continue at video 3. Thank you for listening.